Good afternoon. So it's nice to see such a good turnout, and I would like to believe that it's the interest in the topic or my personality, but I would prefer that it's both. So let's get started. I'll be talking about the Latrobe Valley and its transition to a circular economy and how it will enable job creation and economic activity in the valley. So as with any sort of problem and solution, the first issue is understanding the problem and knowing what that is. So the valley is facing some major challenges. The top of them is the climate change, and the social pressures are leading to brown coal power plants closures, which is increasing the unemployment rate in the valley. In future, this is just going to get worse as more coal power plants are closed down. The other issue is the plastic pollution menace, as it is with the rest of the planet. And finally, the high unemployment rate in the valley. This high unemployment rate, as I just said, is going to get worse as the other coal power plants are closed, and the future automation and AI are further going to increase this rate. Now, solving this or decreasing this high unemployment rate with short-term construction jobs is not viable. We need a permanent and good solution, and it is time to find that solution. So first of all, climate change impacts everyone, even the wicked witch of the north. Now it impacts us directly or indirectly. Australia is specifically susceptible to climate change, as we see with the current drought and the coral bleaching. For us, it impacts directly in our body, our goods, and our bottom line. And indirectly, it affects, for example, when there is a crop failure in some other part of the globe, and the price increases throughout the globe. In future, climate change is going to impact us in the shape of our supers and investment in corporations that were not prepared for climate change. And finally, climate change is one of the reasons that is behind the current trend of migration from the developing and conflict zones. And in turn, this has hijacked the public and political discourse throughout the globe and giving a free hand to the opportunists in the media and in the politics. Plastic pollution. This is another major issue which is not only Latrobe Valley but the entire planet is facing, specifically Australia, with the current ban on export of plastic waste. Now, up until recently, all we had heard about floating plastic debris in the oceans. But recently, scientists started investigating about nanoplastic pollution in the oceans. The idea was that the plastic is being broken down into smaller and smaller particles. So what's happening with that? And the result is that the ocean is full of microplastic. It has now entered in our food chain, and even the sea salt which we consume has microplastic in it. This is only new research that has now identified this microplastic as a cause or as a factor behind obesity, cancer, and infertility. So this got the scientists thinking, and they started investigating about nanoplastic. So nanoplastic is the smallest amount of size of plastic that it can get into. And to the utter surprise, nanoplastic is everywhere. It's floating even in the air in this room around us. Now, unlike microplastic and other debris, the nanoplastic is so small that it crosses, when we inhale, it crosses the blood-brain barrier. Now, this research is quite new, so the scientists at the moment are investigating how it impacts our health. However, I highly doubt it that they will come up with a result that micro and nanoplastic gives us superhuman strength. So it will not be good, whatever the result comes out. So the question is there a solution to these issues? Yes, there is a solution. The solution is transitioning from a linear economy to a circular economy. At the moment, we are living in a linear economy. In linear economy, we extract materials, minerals, and metals from land, we convert them into a product, we use the product, and then we discard at the end of its life. In a circular economy, we extract the materials, metals, we convert them into a product, we use it, and then we send it back for recycling or remanufacturing. For example, our cars. Once we are done using our cars and they are scrapped, in a circular economy they will be sent back to the industry where they will be taken apart and they will be remanufactured either in a new car or in some other product. The same can be said about plastic bags and all other plastic products. At the end of life, the plastic bags and plastic products will be sent back to the industry where they will be melted and remade into same plastic product or some other plastic product. Now the identifying characteristic of a circular economy is zero waste. We ensure in a circular economy that all the products at the end of their life go back, thereby enabling a circular flow of materials and ensuring either there is minimal or zero waste. Now we have a solution. So the question is this solution applicable to the valley? The answer is yes. So in the Latrobe Valley, the issue is that if we want to implement a circular economy, how to go about it? So the way to go about implementing a circular economy in the Latrobe Valley is via biomanufacturing hub. The vision is, in the valley we will use bio-wastes or non-food biomass and produce a whole range of products. Now the four main products that have been investigated are biodegradable plastics, prefabricated homes, renewable fuels, and high-tech products. So right now I will now explain to you the value and the logic behind selecting these four types of products. So these are the modeling and simulation results for such a biomanufacturing hub in the Latrobe Valley. So on this picture here, basically the modeling is basically for this one biomanufacturing hub. So the costs show that with an investment of $600 million, we can have this biomanufacturing hub set up in the Latrobe Valley. This hub will utilize 600,000 tons of either bio-waste or non-food biomass to produce a range of products, four of which I just discussed. And the idea is that once this biomanufacturing hub is established in the valley, those generated products will be value added, further creating economic activity in the valley. So I will now talk about all those four products. Before I begin my discussion into biodegradable plastics, it is important to understand the difference between compostable and biodegradable. Compostable biodegradable plastic basically requires high temperature and very specific nutrients to decompose the plastic. A biodegradable plastic, on the other hand, doesn't need these. It decomposes naturally anywhere in the soil. So in the picture here, we have a PBS biodegradable plastic with a decomposition buried in a soil for 4 months. Now the other benefit of biodegradable plastics is that they are biocompatible. This means that even if we ingest them, they do not harm us. That is why it is biodegradable plastics that are used in capsules and in medical procedures. Now the idea with biodegradable plastics is that we want to use them to replace a vast majority of current plastic products, thereby enabling a circular flow and eliminating waste, or at least reducing it. Now this is one of my favorite products that is possible in a biomanufacturing hub. The idea is that we will use a bioresource and turn it into a prefabricated home. Now this technology is nothing new. This picture is from the 1970s when these prefabricated homes were produced and sold. What we are doing right now is basically substituting the petroleum precursor with the organic precursor. So a few years back I did some calculations on its costing. So I did the calculation for the subcontinent region, and my results showed that a small home which is prefabricated using bioresource will cost $10,000. So it's cheap. But the issue here is not that these houses are so cheap. The issue is the number of homes that will be created in near future. At the moment, there are billions of people who are working towards owning a home. If all of those people construct their homes using the brick, cement and steel as the materials for their homes, the impact on environment will be immense, because all of these are associated with high CO2 emissions. So we need to come up with some ways so that those emissions can be avoided as well. And the neat thing with these houses is that at the end of their life, we can simply send them back to the refinery where they will be melted and remanufactured into the same house or some other product. We can't do this with our current types of homes. This here is basically what the future of a grid will look like. It will be run basically 100% from renewable energy. Now in that scenario, which is going to start happening in the next decade, we will change from consumers of electricity to prosumers of electricity. A consumer of electricity just buys electricity from the grid. A prosumer buys and sells electricity back to the grid. Now the reason that will happen is because of the declining cost of solar rooftop panels and storage technologies such as battery or hydrogen. In near future, the fuel cell vehicles will become affordable as well, and a typical fuel cell vehicle runs on hydrogen. So the scenario will be something like this. We will buy a fuel cell vehicle. Once we reach back our home in the afternoon, in the evening, we are going to plug our fuel cell vehicle into the home. Unlike an electric vehicle, a fuel cell vehicle has an output power. So a fuel cell vehicle can power the home. The thinking is that the solar rooftop panel and will have sufficient power during the day that it will generate a lot of hydrogen. So once we reach back our home, the stored hydrogen will be used, and the fuel cell in our car will use that hydrogen to power our entire home throughout the night. However, current models which are on sale right now, those fuel cell vehicles have an output of 10 kilowatt. However, a typical Australian home consumes 1 kilowatt on average per hour. Now the question is, what will happen to the extra 9 kilowatt? So for example, if I am the owner of such a fuel cell vehicle, I will have two options. One will be just produce 1 kilowatt of electricity and save my hydrogen. However, next day my solar panel is going to generate another specific amount of hydrogen, which will be again extra than my requirement. The logic dictates that I'm going to consume as much hydrogen as possible so that I can sell all of the extra electricity to the grid. Now in a future scenario where only 10% of Australian vehicles change to fuel cell vehicles, they will generate 20 gigawatt of power, which is nearly the amount which Australian grid generates in a typical day. So this is going to happen. The question is, how are we going to balance this grid? So at that scenario, the most important thing will be large scale power storage, because anything can go wrong and we need reliability. This is where the valley comes into play. I think Latrobe Valley has the necessary resources to act as the backup generator for the entire state. So there are quite a few fuels that can be used as a backup fuel, and dimethyl ether is the perfect renewable fuel that can be used to stabilize the entire state's grid for the entire year. 500,000 tons of dimethyl ether can generate 1000 gigawatt of power. That is more than sufficient to balance the grid. In far future, hydrogen from electrolysis will become the ideal gas for backup fuel. However, hydrogen storage is quite expensive. It's not industrially viable at that huge scale. So as the cost of hydrogen storage comes down at mega scale, that is a possible future, but in long term. So the fourth category of products generated in a biohub are for the high-tech industry. Organic products are already used to generate carbon fibers, graphene, composites, and so forth. Carbon fibers have already become a major player in the automobile, aerospace, and the wind energy industry. In fact, it is because of the composites and fibers and their low weight that has allowed the wind energy industry to create the today's wind turbines that have an output capacity of 12 megawatts. Now, because of the properties associated with these fibers and composites, in near future, the industry is aiming for 50 megawatt wind turbine, something that is impossible with steel, aluminium, or other metals. Now, to give you an idea of the scale of a 50 megawatt wind turbine, just 10 of those will generate equivalent power to that of a typical coal-fired power plant, and these are expected to have a 70% capacity factor. The other possible products for the high-tech industry are the flexible and transparent solar panels. On the left, we have a mobile phone charging in sunlight. This phone has a transparent solar cell layer on top of its screen. Now think about the possibilities with such a technology. Similarly, organic materials allow for flexible displays as well. So in the middle here we have a foldable TV that is only possible because of OLEDs. Now OLEDs is already a commercial product. All of the expensive mobile phones today are made of OLED screens. And fuel cells have already started penetrating all sectors of life. And in future, polymer-based fuel cells are going to play an important role, and polymers can be made in any biomanufacturing or organic manufacturing hub as well. Now, at this point, I am faced with a question. If we are generating all of these products, then why not become a part of the biggest industry of the next decade, that is robotics? Now here, so robotics and robots is not a question of if and when. It is happening right now, and it's only going to get bigger. Now this lady here, she is the rising star of the robotics industry. She started her career as a receptionist, very soon climbed up to become a news anchor in Japan, and her name is Erika the robot. And she's just one of the many robots that are under development right now and are expected to work alongside us in social environments in near future. So while Erika is the future, this is today. These are the robots that are in the market right now. So on the left top, we have robots working with their human counterparts at an assembly line doing the same job. Under those robots, we have Robonaut, world's first robotic astronaut at the International Space Station. In the middle, we have the robots that will be available for purchase this year. The two robots on the bottom, one of them is a chef, the other one is a carpenter. And then on the left here, we have the robots that are available for purchase by anyone as of right now. The smaller robot costs $10,000 and the larger robot costs $20,000. And we all know what this little tot will be used for. While we had to learn to type, search, Google, and then cut and paste our assignments, our children, we have to learn the command to order this robot to do the assignment. So look mom, no hands, and the assignment's all done. So what is the way forward for the valley? I think it is right to opine here that for $500 million of investment, a biomanufacturing hub is the best value for money. the economic activity generated by such a industrial hub will be immense. Now I will use the example of a typical pulp and paper mill because many of us are familiar with that. The job creation potential of this biomanufacturing hub is similar to that of a pulp and paper mill. However, while paper cannot be value added or upgraded into something substantive, the chemicals and materials produced in a biomanufacturing hub can be transformed into basically everything around us. These computers, false ceilings, and garments, and all the products that I have just discussed. Now, simulation results show that such a biomanufacturing hub will have a net income of over $200 million. However, my proposal is always to go for the entire circular chain implementation, because that is the best value for money. So I'll quickly give an example. For example, if in the biomanufacturing hub we produce a chemical, that chemical typically sells for $2,500 per ton. If that chemical is then upgraded into a polymer in a smaller industrial unit, its price changes to $5,000 per ton. Now in another industrial unit, the polymer is upgraded into a carbon fiber. That will typically fetch a $20,000 per ton. So at that level, we stop talking about in terms of tons, and we talk about kilograms because of the increasing value of the product. Now, if carbon fiber and composite is used to produce a robot, a 5 kilogram robot sells for $10,000. So this is a 1,000 times increase in the unit value of the product. However, we shouldn't stop here. We should go ahead and implement the repair and maintenance and recycling as well, because they will create more jobs. Now, when we are talking about circular economy and implementing a circular flow, we have to be very mindful of the amount of waste that will be generated in near future. And we can learn from Europe's example. In Europe, they started minimizing waste by implementing waste to energy plants a couple of decades ago, but in parallel they started implementing circular economy. So what happened? Their waste output reduced drastically. So now to keep their waste to energy plants running, they are forced to import waste. This is so severe that now waste is traded as a commodity. So I'll give you an example of Norway and Sweden. Norway has a lot of waste to energy plants. However, its waste is transported to Sweden for their waste to energy plants, because Sweden's waste to energy plants are charging less for the waste, while Norway's plants are running short and they're having difficulty to keep those plants. Entire chain. This is the only unit that requires some major investment, which is of around about $500 million. Anything down the chain basically just requires a few $1 million of investment. For example, these two industrial units. Now there are a couple of other issues that need to be understood as well. We need some sort of synergetic approach between all the players of the economy. And we need to work with the Australian universities to develop courses in the relevant areas. At the moment, there's not a single university that gives a degree in circular economy. And now when we have started working towards a circular economy, and when we progress a little bit further, the only option left will be to import the human expertise. And this lack of human resource is, this paucity of the human resource is going to result in inadequate policy development and uncompetitive industry. However, Australia has a very strong academic sector, and Australia can use its pedagogy prowess to not only become a leader in this area, but also help the policymakers, engineers and scientists from the other countries of the region. After all, we all share this planet, and all of us will have to work together to help save it. And thank you for your patience and attention. That's all. Any questions?